And our speaker today is Rick Ramgattie, and he's going to be speaking about do you require hacking IoT devices by chaining application security vulnerabilities. Rick is a security analyst at Independent Security Evaluators, and Rick has conducted high-end custom security assessments of hardware, software, and he manages a team of security researchers. Rick enjoys being part of a growing community of information security, and he appreciates the art of reverse engineering. That's his main gig, and he's going to be sharing that with us today. So welcome, Rick. Thank you for sharing everything, and we look forward to your presentation.
All right, thanks. Can you guys hear me in the back? I want to stand when I speak. All right, good. That's a thumbs up, so I'll take that as a yes. Like you mentioned, my name is Rick Ramgattie. The presentation is going to be a little bit more loose because I wanted it to be so that you guys can actually watch me hack and see the process where it's just like not clicking a button and hacking things, but see the process that people go through when they find vulnerabilities and build exploits for them. So it's more of like what real hacking looks like. The name of my talk is Introduction to Vulnerability Chains. So this is just not a single vulnerability. We end up chaining cross-site scripting, which is a pretty usual vulnerability that we see, to get an unauthenticated command injection. So there's a command injection that we find by default, but it doesn't have, well, it requires authentication, and we want to see how we can get around that. So first, a little bit about myself. Like you mentioned, my name is Rick Ramgattie. There are the things that I like. I enjoy other things, but those are the things that I enjoy the most. And I'm a security analyst at Independent Security Evaluators. Since they paid for me to be here, this is who Independent Security Evaluators is. We're based out of Baltimore, Maryland. We also have an office in San Diego, California. We do a bunch of security assessment type deals, and we look at mobile applications and web applications, or pretty much if you have something that you wrote and you want somebody to audit. So if you have a custom DRM implementation or something like that, we'd be happy to look at it. I don't see this slide all that often, but I wanted to remind you guys why I'm presenting. So the reason why is that a lot of the times I'll be talking to people when I go to a hackerspace, and they really think that hacking is all about just like using Nessus or like running a scanner and finding out what SSL's cipher suites are wrong. And it's more about like finding vulnerabilities that somebody can use to exploit an application. Or at least that's how I feel. And I also wanted to give the idea that it's not just like somebody who finds these vulnerabilities by saying like they run Burp Suite scanner and they found all these things. It's a lot about like having to do things by hand and reverse engineering protocols, or like looking at a binary for a couple of hours and crying, and then eventually figuring out that it is in fact vulnerable. And then after, like, how to pick out attack surfaces. The device that I have that's down here that you guys can't see, it's by my feet. It's a NAS device. I'm going to be running a demo today and finding vulnerabilities in it. And it's a lot about finding attack surfaces. So it's not only about, well, this is running a vulnerable versions of SMB. It's a lot about saying it's like, oh, it has a web application that has to interface with things on the operating system, and how can that go wrong? So these are our goals today. The first thing that we're going to focus on is that we're going to figure out how to interface with the device, and I've already told you how we're going to do that. It does have an Ethernet adapter, so it's like a normal RJ45. You connect to it, and then after you can interface with it, and by default, most of these devices have a way for you to configure it. If you have a router in your house, which most likely most of you do, you'll have an administration panel, or like if you have a NAS device or an IP camera that doesn't use triangular routing, it's going to be the same. This is the outline of the talk itself. We're going to be talking about what the Lenovo IX4 is. We're going to find the attack surfaces. We're going to find vulnerabilities. There's the two that I already mentioned. We're going to find cross-site scripting and command injection and chain those together. And last, we're going to build the exploit. This is our guest of honor, for those of you that are wondering. It is the Lenovo IX4 300D. This was a device that was made by Lenovo, I think in like 2016, 2015, if I'm not wrong. And it's just a normal network attached storage. It was designed for enterprise use, but people buy the iOmega version of this device for their houses because it's cheaper. As you can see, it has a very small amount of RAM because that was many years ago. And so it just has SATA drives and the RJ45 that I mentioned before. Here are the details that I want you to keep in mind. There are threats that can be internal threats. So like, for example, somebody that already has access to your network, or vulnerabilities that you can exploit through another service. So for example, a browser on your computer, if your computer is on the same network, it does provide an extra attack surface so that you can interface with these devices given the right protocol. The right protocol in this case would be HTTP. There's external threats, so if you could just send commands directly to the device. So if this device is something that you have used for externally facing, so if you use port forwarding so that you can access your NAS from home from anywhere in the world, that's also a threat you should be considering. And the last thing is that the authentication. I mentioned already that you don't need authentication always, even if it is an authenticated vulnerability, because of attacks like cross-site request forgery, you can easily get around that. Here's a list of things that I want us to get. We want to get a remote shell. We're going to exploit that command injection and cross-site scripting that I've mentioned so often, and these are the places that we're going to get it. So a lot of the times when you work with anything that has to interface with the ability to create directories and remove them from a embedded device or from anything else, so even if it's like some PHP web application on a real server, if it has the ability to interface with a directory by creating it, deleting it, or creating new shares, for example, that could lead to command injection. That's one of them that we'll see today. Or if it has another functionality for curling a URL, that's like anything that it has to, we're relying on the operating system to do something for us. One of the common ones that we see, if any of you played the IoT Village today, is the ping utility, because ping is something that, like, most of the time they just, instead of rewriting ping, they'll just use the one from the operating system, because it makes everything a lot easier. And it also, like, it's the idea of reusability instead of having to make new code every time. Sweet. So let's dive in now and look at the device. So if I have Firefox here somewhere. So this is just, that's not Firefox. 1 minute, let me figure out my displays. Or if I exit presenter mode, that should help. Alrighty. So here is just a normal web app. We'll go to the home page so that you guys can see what it looks like. And when you buy one of these Lenovo NASs, this is what you get. It's like a normal web application so you can interface with it and do stuff. If you click on the slideshow, you get to see all these pretty things. It's like, well, which really doesn't matter for right now. But there's also the content page. As you can see, there's like some command injection attempts that I've already created in some of the shares for this demo. I'm not going to use the reboot one because I don't want to shoot myself in the foot. But I do want to show you guys some of the other functionality. So here are all the features that it provides. As you can see, it is a very rich feature set. You can also see that it's a little dated because I don't know if Flickr is still a thing. But it is, like, it does provide a lot of functionality. And one of the functionalities is the ability to create shares, which is right here. So if you look at the first one, it's just like I used backticks and curl to put in, or backticks and then a curl and some IP address to test for command injection. In this case, the reason why I used backticks is that it's a good way to escape where the current shell, or like the current thing that you're shelling out of, and then have to execute your own commands. You could also use other characters, like for example, $ and parentheses are a good combination sometimes for testing out for command injection, but there's a blacklist here. And it's this is a good example why blacklists are not a good idea. Blacklists usually lead to you eventually missing something that shouldn't have been in there. And in this case, if this share is ever renamed, deleted, or moved, it's going to issue this command. The only problem here is that the blacklist also removes slashes, and this is from that current directory. So I want to get a remote shell. And I didn't have the ability because I didn't have hyphens or attacks. So that was another character that was blacklisted, and I want to use netcats -e functionality to execute a command. So instead of going through the headache of trying to write things to a file and then execute the command, which would be another option, I decided to hunt for other command injections. And the other one is over here in the personal cloud feature. So here we can connect our Lenovo device, our NAS device, to a cloud server so that it can synchronize between your Lenovo devices. And this is not the one. When you add another personal cloud, you can name it whatever you want. So in this case, I'm just going to call it test so that we can see the request. And I'm going to intercept this request with Burp Suite so we can see what the post request looks like. So if we click on apply, it will eventually issue the request. And after it issues the request, we're going to see that what the post body is going to look like. Come on, buddy. So while Burp Suite is figuring that out right now, I'm just going to go ahead and close it and reopen it, because that seems to be a way to get Burp Suite to work. And then so we'll see that every time this request is issued, it's just going to be a normal post request with the content of the commands that we want to run. And in this case, we'll see that, reload this page, turn off intercept, turn it back on. We'll see that it's going to have the word test in it. And in this case, the password field is also vulnerable to command injection. So let me try to debug this right now with you guys on the fly. We'll check out and see what Burp Suite's up to. So usually it should be configured so that it is on localhost and port 8080, which it is. And then after, we're going to see that this is also on localhost and port 8080. We'll close Firefox. We'll open back Firefox. Not now, Firefox. No updates now. But anyways, so we'll see that we can issue this request. And after, when we see the ability that we can issue this request, we'll get into the good stuff. Okay. Proxy, intercept. It should be logging in right now. Still not intercepting. Well, the good thing about it is that I already have a backup because I know something was going to go wrong. And here we can see the request. Here we can see that the cloud name is just test, as we saw before. We saw that the username is test and the password is this base64 encoded, or URL encoded string. So let me move that over to Burp's URL decoder, or just decoder functionality in general. We'll look at it a little bit better there. Code as URL. And we'll look at it a little bit better now. So I'm guessing most of you can see it, but that is the command injection payload right there. It's like so all versions of Netcat, or the ones that we mostly run into, don't have the -e flag for a good reason. It's because whenever this listener receives something, it's going to launch it with a shell. In this case, the shell is /bin/sh or sh, and it's going to be listening on port 9000. Every version of Netcat that you have right now, if any of you run Linux, doesn't have this anymore, and there's a good reason why. It's because you shouldn't be able to just set up a listener so that you can execute commands. But if the device that you're looking at has BusyBox, almost every version of BusyBox that uses Netcat has the -e flag, so you're allowed to do this. So this is just a bind shell. I could have easily used a reverse shell if I wanted to as well, or I could have just set something else up because it does use sockets, so I could have just used bash to set up a reverse shell with sockets, but this is enough for me for it to work. Now, close this, and our device is 192.168.2.6. So if we issue a request with the right values, it should work. So one of the things is that we're going to need one of these values because it's going to be updated every time we log in, and we also need the iOmega cookie, which is here. So there's two details about this that I've already given away, and that's that we need the C value and the iOmega cookie. If not, the request won't work. So now if we connect to the device over Netcat, we type in ID, we have a root shell. This is usually where you clap. Yeah. But we're not done, because there's an important part here, and that's this is authenticated. I was only able to execute this command because I knew the value of C and I knew the value of iOmega. So usually you'd be able to say like, oh, it's an authenticated request, they're using cookies. That means we can use cross-site request forgery. But there's a problem. The C token in the URL acts as a CSRF, like a CSRF mitigation, because you have no way of knowing it, unless you have a way of pulling it out of the browser. So next up, we need to figure out how we're going to get that C value out of the user's browser and into a request that we can issue. Usually when we want to interact with the browser, there's one thing we think about, and that's JavaScript. And it is the evil that we usually end up dealing with. So let's go ahead and look at what's in our browser's storage. The cookie we're looking at right now, let's look at the value again. It's, we'll just say 2699 because I don't want to remember that many numbers. So we'll look at 2699 in the storage and see where it is. And it's not in the cookies. It's not in the index browser, but it is in local storage. So that means that if we can somehow use JavaScript to pull out that iOmega user cookie value, which is also the C value that we saw before, then we'll be able to issue this request unauthenticated. So let's look for cross-site scripting. And this one is going to be way better because I don't need to rely on Burp Suite. So one of the interesting features of this application is that this token right here ends up in the page. So let's, instead of calling it cat, we'll call it Eric. You're welcome, Eric. And we'll look for it here in the HTML. I typed in Eric. And we'll zoom in real quick so that you can see it. The value from the CAT parameter ends up here. And it's also funny because it's in the security.html page. So what we're going to do is that we're going to exit out the zoom and we're going to try something else. So we'll call script alert 1 script, and I'll let you know right now that this is not going to work. We're going to look at it. Why? And if we look at the source, we're going to look for the alert 1. It's probably the easiest one to find. And it's because we haven't exited out of that A tag. We're still inside the href, attribute. So if we close it off, and instead of alert 1, we'll do hi Eric. We'll see hi Eric. So now we have cross-site scripting, and this one's pretty easy. So we need to figure out how we can use cross-site scripting now to execute this command and pull it out. So for that, I prepared a small JavaScript thing. It's called BSides Tampa, or just Tampa, I think. We'll zoom in so that everyone can see it. And this is all the JavaScript you need to own any Lenovo device that runs like this, or like any Lenovo device that's IX4 that has not been recently updated. So at the top, you see that we just create an SXR, we set everything to const because we're not daemons, and we just use the local storage to get the item iOmega user cookie, the URL for the device that we want to look at, which in this case, it's not this URL. It's going to be 192.168.2.4, 2.6. And then after, this should just work. And if we're all lucky, I did. Good catch there, mate. And let's just cat it to make sure that it's all the same, since everything seems to be going wrong today anyways. And we'll see that it's the same. So we'll just host it with Python simple HTTP server. I should be 2.1 -m simple HTTP server. So it's listening on port 8000. Now let's see if it works. So we know that this is the name of the file. Let's go ahead and set the script source to be equal to http://192.168.2.1, and then after we closed our slash the name of the thing that we're looking for, and this should go ahead and fetch our script, which it hasn't so far. Port 8000. Thanks for the help. Set it up on port 8000. So they did a 404 for the first one, So let's see why. Lenovo XSS Tampa.js. Let's see why. Lenovo XSS Tampa.js. I don't think I need to see if that'll work out. I think that I have an ending quotation marks here. So if I do script, let's see. We're debugging live again. So let's see. It's okay. So that time we got a 200. So if we open up another tmux pane and we connect to it over netcat, we should have a shell. And let's see why that didn't work. 2,000. No, this should be 9,000 because this is the netcat listener we set up before. So let's look at the script again. Lenovo X, or if we look at Burp Suite's history, it'll say it in there. So we send a post request here, and here's the body, and what was the response? And so it's saying that it couldn't find the personal cloud instance because it may have lost internet connectivity, which would suck. So let's see if that is the reason why. Okay. And let's see if the device still has the same IP address, which it should, because if we were able to interact with it, it should. Okay, so that's not the reason why. Let's see what Burp Suite said this time. The most recent request, it was able, just so that we're following together, it was able to get the script. It ran the script. It did go to the 192.168.2.6, and it did issue the request. At least, and that we'll see here. So, so it's saying a page is not found. So the reason why is because I put the IP address in the wrong spot. So let's look at that script. Live demos. So we'll go ahead and edit that script to make sure we don't have that mistake in there anymore. And for this part, I think we can remove this guy. Let's see what we'll get this time. So we'll set up the Python simple HTTP server again. And we'll wait for it to refresh. When it refreshes, it should get the file. I got the file. Let's look at what is said in Burp Suite. And this one might have actually worked. So let's go ahead and look that up. Jesus. So there we do have a shell. So now anybody who we can get a trick into visiting or a page with cross-site scripting, or if we could just trick them into getting a URL and clicking on it, then it would work. There's a catch here. This cross-site scripting vulnerability specifically only works in some browsers. For example, it does not work in Chrome because Chrome has an XSS filter and it does stop this. It does work in the most recent version of Firefox, so it does stand since a lot of people do use Firefox. And on top of that, it also stands because it is pretty often that people log into their NAS device because they want to interact with it, because it has all this crazy functionality. Now with root, there's a lot of interesting things that you can do. So as you can see, you have full control over the device, and now you can use the device to pivot and to access other devices on the target's network. You can also see how the device, like what's stored on the device, and for example, steal it or store other information that you want to on there as well. Sweet. So that's we were able to combine both of those to get a shell, which is exactly what we wanted. And it was less painful than I thought it was going to be. So the top one, we got command injection, and the cross-site scripting ended up working. We were able to figure out how we can get those post parameters because we saw that there were only 2 tokens that we needed. The one that was already sent through like normal cookies, because that's how cookies work. And then the one that was in the URL parameter that we were able to get with cross-site scripting. Then after that, we combined it all together, exploited a simple command injection, and we got a show. So here are some of the... Thanks. Yeah. Sweet. So the things that I do want to talk about are these. So a lot of the times, I guess, people just mention that, oh, well, it's an IoT device. Well, I just won't buy one. And for example, this is a NAS. It's not necessarily an IoT device. It's not a camera or a light bulb or whatever. It's not a fridge. But it is something that you own. So the same thing applies for routers. The same thing applies for anything else that's like prepackaged with some Linux operating system or some RTOS that you own and set up in your house or your business or wherever else that you want it to be. There's also the problem that you don't really get to choose which one of these devices you interact with sometimes. If you work at a company and they have these things, you're not just going to say, well, you can't have that NAS device because I heard it has vulnerabilities. You probably should be able to say that. But at the same time, it's not like you're not going to find all vulnerabilities in all devices. It's just a reality that we all need to accept. So and then there's a similar thing that if you visit a hotel, for example, and if they have a IoT shower head, your choices are to either leave or just stay. Yeah. Like you don't get to choose. Here are some of the things that I recommend for if you're a manufacturer or a consumer. If you're a manufacturer, you probably should just get your stuff audited. If you don't want to hire a separate consultancy, then just do it yourself. I don't really care. But have somebody look at it. And then having security built into your SDLC is very important because it's way harder to fix vulnerabilities after it's done than it is to just say all right, cool, let's talk about how to not put vulnerabilities into our code. Obviously, some are going to slip by, so you do need an assessment at the end. You should probably do that, but it's probably going to be less, and it's going to be less of a headache when it involves re-architecting your whole authentication system. Long term, you probably should just send your devs to a security training. You should probably send your security people to a security training too. And talk to professionals. There's a bunch of people out there. I personally ask other people when I don't know. I may be a team lead at my company, but I also ask other people and I ask my team because it's important. And short term, if you're a consumer, is that if you buy one of these devices, you should probably look at what services are enabled by default. If you don't need your web app to be enabled on your NAS device, then turn it off. A lot of the times routers ship so that their web application are accessible from the WAN. So anybody, anywhere in the internet can access your router. It's probably not a good idea, especially if you don't need it. You should limit your attack surface. It's a very good security principle. And updating firmware, it's kind of hard, and I do feel bad about saying it because it's not necessarily you're going to update your firmware and everything's going to be hunky-dory, because it happens to be the case that if the manufacturer doesn't know about the vulnerability, there's no way for them to fix it. There's no firmware update if there's command injection and no one has told them about it. Long term is to request better security in your devices. If you like a specific manufacturer and you've noticed that they have very poor security policies, you could just say hey, I'm not buying your stuff anymore because you don't fix it. And as I found out through the magic of Twitter, usually telling people that their stuff is garbage ends up with them fixing it. Yeah. And that's kind of the end of my talk, folks. I hope you enjoyed it. That's kind of what hacking looks like from the perspective of my day-to-day. If you have any questions, I like talking shop. I'll be here for a while at the IoT Village. I work with the people that put on the IoT Village, and this is what I do in the research team. And thanks.